about transforming a function. Okay, and the first thing we're going to do is try to get an idea of what a function is. Okay, so in grade 10, you guys would have probably been used to writing something like this for a quadratic. Y is equal to, some numbers with our variable x, a couple other numbers, blah, blah, blah. They call it trinomial. Here's an equation. Okay, and then here's another equation. Imagine this one is in here. Y is equal to 3x minus 2. But if we already say y is equal to this, and then I say y is equal to that, I'm saying that these two things are equal. But if I want you to graph something, I need a way to describe different equations. And if I keep calling things y, then that infers in math that these things are all equal. And maybe they're not at certain points. So we use something called function notation. So instead of writing y, and they use the letter f because it stands for function, okay? And we say f with the variable x in the equation. So this is a relationship of a function with a variable x. And I can rewrite the exact same thing. Okay? And then if I wanted to represent, and this one was a quadratic, I'm not sure if you can tell, but it had an x squared. And this one is only to the power of 1, so it's linear. We usually don't write the 1. But if I want to represent this now, okay, I wouldn't write f at x. F at x stands for this specific quadratic. I would write a different letter. Let's call it g at x. Okay? So the function, we'll call this function g with the variable x in it is equal to 3x minus 2. And using this concept, h at x is equal to 5. Okay? So just some horizontal line. J is another code, could be equal to 3x cubed. Okay? Every letter, when I refer to each of these letters, okay, f at x, g at x, h at x, j at x, they all are equal to different equations. Now, you sure use 3 a lot, eh? Okay, so they're all equal to different equations. This is just a way of categorizing them. Otherwise, we would have wrote y is equal to these, and then when referring to them, it'd be hard. I'd have to tell you why I want the equation that is equal to 3x cubed, or I want the equation that's equal to 5. When we give them functions, I can say I'm looking for f at x, or I'm looking at h at x. It's a way to really describe many different equations. Okay, so that's just a quick concept of why we use this new notation called functions. Okay, now with that being said, we're going to talk about transforming a function around a page. So I'm going to start with what's known as a root function. So I'm going to call it, we've already used f, g, h, j, we'll call it k at x, okay, is equal to, and we have some specific letters, a, and because I called this k, actually no, we'll do the root function, we square root. Now I know we haven't talked about square roots yet, that's the whole point of this. I'm going to show you what some new things will do, minus c, and then outside the function we have plus, we'll use orange, maybe d. Okay, so we'll talk about what each of these do. So think of it like this. A function, okay, you could have said a function. These 4 little variables, a, k, c, and d, they transform things around the page. They move it around a page for us. So anything under the function, so for instance, this is a root function. It could be squared. It could be absolute value. It could be linear. It could be cubic. There's so many different types of things. Anything under it, so the k and the c, they will deal with horizontal changes, okay? So C deals with horizontal shifts, and we're going to talk about exactly how, okay? K deals with horizontal, and I'm going to call them stretches and compressions and flips, okay? So S, C, and F, so stretches, compressions, and flips. Can you memorize? That's okay, those letters? Okay, good. And then anything outside the function, so it's not under our root, it's technically outside our function, that's our A and our D, they deal with vertical things. So D, oops, orange, thank you. What's going on here? I want orange. Okay, D deals with vertical shifts, so moving the function up and down. If you remember quadratics, this was commonly the letter K. They usually use the letter K for that one when transforming a quadratic. And A is the same if you remember from your quadratics. A is the exact same thing. A deals with vertical stretches, compressions, and flips. Okay? So the A and the K have similar effects, except one's horizontal, one's vertical. And the C and the D have similar effects, except one's horizontal, one's vertical. All the horizontal ones are underneath the function or in the function, and all the vertical ones are outside the function. So let's see what we actually mean by this, because there's a lot of words. Okay, so the very first function I've called f at x. Okay, so I've turned it on. There's our first function, and that would be the equation y equals x. So we have our linear line. It's pretty obvious to see. Okay, and if I were to d, okay, if I were to change d, so if I were to increase it, you'll see, and this is the red one, it's technically moving upwards. I know it looks like it's moving on an angle, but you're technically moving up. As we move it down, or as it comes downwards, it moves downwards from where it is. So that's showing what a d does. D moves things vertically, up and down. Okay. C does similar thing, except this one's moving it to the right and then to the left. Now, with a linear equation, it's really hard to tell these ideas because it really just looks like this thing's moving on the diagonal. Okay. I just want to show you the general ideas. K is giving it a horizontal compression as the number gets larger, and then it's going to stretch it, so it's going to bring that slope down, and then it flips it, okay? Again, kind of hard to see with linear ones. So instead of using, this is where that function comes in handy, instead of using f at x, we're going to deal with g at x, and g at x is a quadratic. So all I have to do is change the letter here, okay? And now I have a quadratic, okay? So my quadratic's changed. So let's watch that again. D moves things down and up. Okay, so see how we changed the d value? It shifts things up and down. C moves things to the right as it increases, and then to the left as it decreases. Okay, let that come down. Okay, we'll do A because A is what we're used to seeing. As A increases, it gets thinner. It's called a vertical stretch, right? And then as it gets smaller, it gets wider, 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 and then when it's negative, it flips. Okay, and then K does the same thing except horizontally. It flips back and forth, okay? And again, with a quadratic, a little hard to see because we're not used to seeing this k idea. So again, instead of showing a quadratic now, I'm going to show you a whole different function. This is a root function, okay? So it's a square root. And instead of using g, okay, I'm going to change this letter to h. So now it has a root function. Now this one's a little harder to see, so I'm going to flip it back up and flip it back around, okay? As you can see, d moves it up. We already know that. I'll just go quickly. Up and down. C moves it left and right. Okay. K gives it a horizontal compression. So think of it like things on the outside are squishing it together. And as it gets smaller, it's pulling it left and right. Okay. And then as it flips, it goes to the other side. And negative flips it on the y-axis. And A flips when it's negative on the x-axis. So it goes down and then comes back up again. So that's what all of these letters will do to different functions. And it doesn't matter which function we have. I can move other ones. This is called an absolute value. It's like this big V. We'll change this letter to I. There we go. And I'm going to turn them all on at the same time. And you see a whole bunch of crazy things happening. And it's just shifting it all around the page. C, D, K, and A. And you can see you can move a function anywhere on the page, making it do anything with these 4 letters. Okay. Let's turn them back off. So that's the general idea for transforming a function. That's what A, K, C, and D do. They do specific movements of things. Okay?